Hello, welcome to Cpp.chat, the other only podcast for C++ developers by C++ developers. CppCast changed their intro and called themselves the first, so I don't think we can continue to call ourselves the other. So we may have to call ourselves the second only podcast for C++ developers by C++ developers. But anyway, before we continue, I want to read this week's disclaimer. We are not lawyers, and this should not be considered legal advice. You should seek appropriate counsel for your own situation. So, programming by contract is one of the most useful and powerful programming paradigms in software engineering. Although this paradigm is used by hundreds of thousands of C++ programmers, there is no direct support for it in C++. But that's changing. A proposal to add contract support for ISO C++ has been voted into the draft for CPP C++ 20. So in this episode of CPP Chat, Phil and I are going to be discussing this proposal, and we have some guests that have opinions on it. So first of all, hi, Phil. How are you doing? This is Phil Nash, the show's producer.
Hello again. Good to be back.
All right. Anything we need to say before we dive in? I guess we're gonna have some small announcements. Is there anything you wanted to say before we get even to that?
Just to remind everyone that the C++ on C call for papers is still running to the end of July. Now would be a great time to think about submitting, since all the other big conferences have finished theirs.
Okay. All right. John Lakos, one of the proposers of the proposal that we mentioned, is going to be joining us. John, hi. How are you doing?
I'm doing well, thank you.
All right. So how long have you been working on this proposal?
Well, it depends on whether you count how long I've been working on it as part of the C++ Standards Committee, or how long I've been working on it to try to get it as a proposal, or when I first got involved in doing this. So I'll try to answer all three. The first version of our internal mechanism was created around 2004, and it was revamped in 2009. And then I think it was first proposed, it's hard to remember, I think it was around, I'm guessing 2000, maybe 13. Anyway, we tried for a while, and it seemed as though the use of macros and the possibility that there might be some question of ODR violations really made it very difficult for people to accept it in the sort of the new spirit of C++, which is understandable. There's also another faction, which is the idea that we're doing compile time static analysis as opposed to runtime checking. And ours was all about runtime checking and not static analysis. So there was this little, maybe a disconnect. So I think it was around 2015, we're in Rappersville. I hope I have the dates right, but I might be off. Anyway, it might have been 2014, but anyway, the last Rappersville meeting, it kind of didn't make it, and we realized it was important, and then Nathan Myers pulled sort of the proposal out of the garbage can and introduced the ability to do compile time introduction of undefined behavior as a result of violating a contract, and this whole thing was reborn, and that's really the genesis of the paper that we have right now.
All right, we're going to dive into that a little bit more, but let me first introduce Kévin Boissonneault. Kévin has some thoughts he wants to share about contracts. Kévin has kind of taken over the CPP Lang Slack. Every place I look, he's there. Do you do anything other than type on Slack? I'm just curious about this.
I mean, just while compiling, this is C++, so that's significant
lots of
amount of time.
times.
No, but I mean, if you see me on every channel, that means we just have the same channels in common. I'm really not on all of them, but at least I'm on general, I guess.
Okay. All right. Just seems like I see you a lot. Okay. So we do have a few things we want to talk about. CppCon, well, actually, I think we did talk about, we have announced a call for volunteers in the grant program. And I think this is really, really important because there are people who are not yet in a position to be a professional programmer, or they're working in a company that's not going to send them to the conference they want to go to. And this new grant program will allow people to be able to attend CppCon who, for financial reasons, couldn't do it otherwise. So I'm really excited about that. C++ on C, Phil has already said the call for submissions is open. When is that going to be? When's the conference itself?
Conference itself will be next February, the 4th to the 6th.
Okay, so very early next year.
That's right.
And it's along the seacoast, which is why you call it this. It's on the White Cliffs of Dover.
Clues in the name.
Okay. All right. Any other excitement going on in the C++ world? I think we're all kind of trying to still absorb what's happened at Rapperswil, right? That seems to have been an important meeting.
Yeah, we're still unpacking all that, I think. Stuff's still coming out. I heard that the deadline for the post-Rapperswil mailing is next week. So I think a lot of people are getting ready for that as well.
Yeah. John, other than contracts, anything interesting happening at Rapperswil that you want to briefly mention that you think we should be paying attention to?
Well, I got to tell you that I was there for an extremely short time. It's my shortest attendance ever since starting in 2007. I was asked to go down to Lugano, where we have an office, and talk about some things that are going on there. Modules in particular was one of the things that I focused on in Rapperswil. So that was my only focus pretty much in Rapperswil. And yes, I'm very interested in that. I was asked in 2007 to get involved, and I regret that I said, well, gee, not really all that excited about it. Now I realize that I should have gotten involved sooner.
Yeah. Yeah. If you want something done right.
Well, at the time, I had no idea that we needed modules.
All right. So I think we're going to have in the show notes, we'll probably have a link to the proposal. But give us the nutshell, John. What got voted in? Not the whole proposal, just what got voted in. What do we know we're looking at, assuming it doesn't get voted back out, which is theoretically possible, but unlikely?
Well, you're actually asking me a question that I'm not prepared to answer because I wasn't there during the end of the meeting. I was there during the beginning of the meeting. So maybe you can tell me what did get voted in, because that's news to me.
Well, I think most of the proposal got voted in. That's kind of what I was assuming.
I thought it was all of it. It just made it sound like there was something that didn't.
No, I'm not saying that. What I meant was that I think, I guess what I'm saying is, without going through all the history of what was proposed and all that, just what actually, what is the final
I understand.
flavor?
Okay, so the proposal that went to Rapperswil, I can talk to you about that.
That's what I mean.
Okay, there you go. Okay, good. Okay, so in the beginning, as I said, there was what my contribution was the runtime checking. Then hang
on, John. I realized I am already getting ahead of myself. Let's forget the proposal. Let's talk about programming by contract. What the heck is programming by contract? I'm a huge believer in this. In the Slack channel, because I asked if I could quote him, but he hasn't got back to me yet, so I'm not going to mention his name. But somebody in one of the Slack channels today said that I don't have the exact quoting, but he said it's frightening how many people in LEWG don't seem to understand. Well, he called it design by contract. And he was pointing out things that have gone into the standard that kind of don't make sense from a contract's point of view. So what are we talking about when we're talking about programming by contract?
Okay, so I want to say, just like anything else that's really important and basic, is it's obvious. Do we really need to talk about it? But the answer, no. But I'm going to, because it is probably the most important teaching opportunity I have at Bloomberg. And in fact, I can't even tell you how many people everywhere don't understand it, and it gets more and more nuanced as you go along. But just to make it very simple, the idea, and I have spoken about this with many people, including someone we all know and love named Alex Stepanov, who sees it pretty much the same way. So there are a lot of people who are very much in agreement with this. When you go to do something, you have to make an agreement with the person who's asking you to do it, and that's called a contract. And design by contract, I believe, is somehow under I don't know whether it's a trademark or copyright or one of those funny legal things for that it is now I'm trying to remember, is Bertrand Meyer, who originally was the one who made it very important. And put it in Eiffel, right? And I believe that as a term, design by contract, comes from Bertrand Meyer, and I use it freely because I don't think that's something that you really want to restrict, because it's just too useful a concept. Anyway, design by contract says, listen, tell me what I'm going to tell you what I'm going to do, but I'm also going to tell you the conditions under which I'm going to do it. And so, the classic example that I start out with is, suppose you want somebody to paint your house. You say, okay, I want you to paint my house. Well, what exactly does that mean? Do you mean the outside, the inside? What exactly does painting the house mean? Okay, fine. Now, and then what's the precondition or whatever for the person painting the house? You have to pay me. If you don't pay me, that's no good. So if I pay you, you will paint my house. And then what's interesting is well, what else are the preconditions? Well, there has to be a house and so on and so forth. You can go into all of it, but it's what the person who's asking of the service has to provide and ensure. And then the service provider will call that the post condition, or we'll call that the essential behavior in computer science, because it's not just the static properties that hold afterwards, but it's also the rate at which it's done and under what circumstances, like is it thread safe? So there's more to it than just post conditions, actually essential behavior. But the contract provides the preconditions and the essential behavior, which includes post conditions, of what will happen if the preconditions are met. So that, in a nutshell, is...
So potential preconditions are things like, I'm only going to pass you a positive number because I'm asking for square root. So one of the preconditions might be, has to be a positive number, or has to be that the pointer I'm passing you has to point to a valid object of whatever type. Those are the potential... This is a
great opportunity. I just want to interrupt. This is a perfect opportunity to show why contracts are so important. When people speak, they say, oh, it has to be a positive number. Do you really mean a positive number? What do you really mean? You mean a non-negative number. And contracts force you to think about boundary conditions, and that's one of the things that makes them awesome.
Right. They're better than comments on that regard, and that comments might be ambiguous, while contracts would use an actual C++ expression.
Wait a minute. When you just said what you said, Kevin, I think what you were saying is that having contracts in the language, because we haven't talked about the language yet. We're just talking about conceptual contracts. And see, that's the thing, is that essentially everyone who's writing software that works is using programming by contract in practice, because you have to. If you aren't thinking in terms of, before I call this function, these things have to be true, then your code can't work at all. But just because you're using it in practice doesn't mean you're understanding the discipline and following it consistently. In order to follow it consistently, you need to document what those preconditions are and document what that essential behavior is. And that's, I think, a complete missed opportunity. And that's what I think the person who was speaking in the Slack channel that I was quoting, that's what they were saying, is that there's a lot of people who don't follow that and don't think about the implications of what it means. And I think one of the things that when we're taught programming, we're often taught, well, validate your input. Well, one of the things is you can't always validate input. You can never know if the pointer you're given is pointing to a valid object or not. Who knows what it's pointing to? You can't validate that. That has to be taken on faith. There are some things you can validate, but there are things you don't want to validate for performance reasons. If I have a function that's part of the internals of my app, I can know the only person calling it is me, and the only 3 places I call it, I check those conditions before it's passed in. So the function has a set of preconditions, but the function itself is not responsible for verifying those. But for performance reasons, but they are there. And it is possible, and this is what John said, it makes sense to put some of these things in the language. Trying to verify these things with macros or other techniques is quite valuable. A lot of people are doing that, and it works to some extent, but we can do so much better.
Okay, I would love to jump in here. You said something about validating input. One of the greatest opportunities to screw up contracts is if we don't explain what we mean by input. If you get something that is coming from outside of trusted input, a trusted environment, you're doing something, trying to assert it is a mistake. people will send you bad data. People that either you don't trust, or they just don't care, or they're just sloppy, and that's okay. But we're not talking about data here. When we're talking about contracts, we're talking about calling a function that is not data, that is somebody who can't read or doesn't choose to read or is just not doing their job, but they should be. They're not calling your function in the way that it was intended. And that's very, very different from getting something over the wire and it isn't in the right format. So I just want to be clear, validating input is not what we're doing. We're validating arguments to functions that are bound in, that are part of a safe environment.
Well, when I said input, that's what I meant. Arguments passed to functions.
Well,
I understand that's different from what you're talking about.
But contracts are all about being, contracts are all about being precise about what we mean in English. Can be taken, I mean, especially spoken English can be very, friendly and affable. And I'm often criticized for not being friendly and affable and taking English casually. And so I use contracts very precisely. So when anybody ever says positive number, they say validate input, I get my knickers in a bunch and say, no, please. Because if people do assert inputs or assert the configuration of a, let's say, a particular file or whatever, that can change. And when that changes, the program crashes. And that's not what we're talking about. We're talking about things that should not crash. And if they do crash, it means that there's a software bug, and that software bug needs to be fixed right away. And this kind of assertion is telling us, hello, stuff is broken. It's broken here. You need to fix it.
Okay. All right. So I hope that listeners can imagine the kinds of macros ones could create to try to create a formal way of doing contracts within C++ without language support. But now we've got a proposal that has now been voted in. It's in the standard targeted at C++ 20, and this is what John has been working on for a while. Can you? This is what I asked you before, and I cut you off, John. So now I'm asking you. Can you talk to us about what kind of language support we're putting in to support programming by contract?
All right, well, this is the interesting part. The proposal that I originally suggested in 2000, well, I'll say the one that I was finally hoping to get done in Rappersville the last time, did not have the kind of support that this one does, because we were interested in runtime checking. Runtime checking really doesn't need language support. Macros work fine. However, the compiler isn't as able to reason about the static properties of the assertions. So the other side, the other authors, really are not interested so much in the runtime checking, but they're interested in the static analysis. And the static analysis is the preconditions and postconditions in the interface, so that looking at just interfaces, static analysis tools on a large scale can do something. So what this proposal is it's a combination of runtime checking, which is what we need, and compile time checking, which is what other people feel they need. And so we put them together into one package that does runtime and allows for compile time checking. And that's what was proposed. And I can go into more detail if you want as to what's there.
Well, let's do exactly that. Let's talk. I mean, we don't have video. We can't actually show people the syntax, but we can describe it briefly.
All right, well, the specific syntax is what we call byte shedding. It doesn't really matter. What's important is the information that you want to communicate in the program. So, for example, let's take something that everybody knows, which is square root. Now, if you want to do runtime checking on square root, it's very simple. At the top of the body of your function, not in the interface, you put a statement that says, if the program is at this level of assertion checking, then I want to execute a predicate that verifies that what's coming in satisfies this particular condition. And if this condition is not satisfied, I'm going to call a global function. And that's it. That's all that a precondition contract is. Now, the other side of the coin is, suppose I want to say that in the interface. Now, a lot of people argue, why would you want to say it in the interface? So some reasons for saying it in the interface are, then I don't need to write the English. I'm going to flat out disagree. You need to write the English anyway. then some people will say, well, of course you have to write the English, and that this is just a subset, and I can get into that a little more. But by putting it in the interface, then static analysis tools that are not the compiler, or even the compiler itself that does not have access to the implementation, and by implementation I mean the .cpp file, not inline functions, then they can analyze it. And if it were only in the implementation of non-inline or non-template functions, they wouldn't have access to it. So that's the reason. Those are the two reasons. One is to eliminate the use of English in describing contracts, which I strongly disagree with. And then the other one is to make the information available to compilers. And one example of using that is if I have a function whose range is not consistent with the domain of the function that it's going into, then a static analysis check without any testing can say, hey, wait a minute, my input has to be positive, as you say, and what's coming in is going to provide a negative result. Therefore, this is broken. We don't need to run it.
Mm-hmm.
All right. So what you're saying is that the big feature from the language point of view is that tools now have a better way of understanding what a function's intended to do. Because right now, of course, there's no way to know what a function's intended to do other than the fact that it takes certain types. And
what's interesting is the point at which this thing, which was almost in the garbage can, came out by Nathan Myers is he used C++03 technology to cause undefined behavior to occur if the predicate was broken, which allowed the compiler to eliminate code and do optimizations without rewriting anything. And people went, wow, that's really cool. Let's put that in the language. So we have Nathan to thank for rescuing this thing and getting everybody on the same page. And by the way, at the time, Nathan worked at Bloomberg.
Right.
I hope I'm not discrediting him by saying I think it's the most important thing that he did while he was there by far, because it really made a difference in this whole. I really don't think the contracts would have survived without it.
All right.
Did you have something you wanted to say, Kevin?
Well, no, like he eventually brought up the point I wanted to make. Like he mentioned static analysis, which was the benefit of the new part of the proposal over his original proposal. But then, yeah, there's also the optimizations, which is something compilers already did with standard library function. If I call memcopy, a compiler can assume the pointer I used there are not null and do the optimizations in consequence. And now the new language feature also gives me that power for all my functions, really, because now the compiler understands really what my preconditions are and stuff. So,
right, because before that could only be done for things in the standard library, but now essentially a user can specify and say to the compiler, assume that you're never past a negative number for here. Assume this is never 0.
Right, and you know. Don't check for null 12 times. Just check it once in the first function, and you know the rest are the same precondition. And well, that's part of that. So the undefined behavior gives optimization opportunities, but maybe we can mention that later. But I know, for example, someone in this chat would mention that for them, undefined behavior is also a problem, which can cause the compiler, for example, to optimize away code which really should have just been left alone. So they can, but we can go in detail later. But yeah, to me at least, the undefined behavior or the check is really all that I need. But that's what I really like with this proposal. Anyway,
someone in the chat is saying that compilers already use asserts as optimization hints, but I think the point there is that they can do a lot more.
Right. I mean, now they can do so from the interface, right? Otherwise, they would need to see the definition of the function. I mean, there's always the argument for, well, link time optimizations, and sure, yeah, link time optimizations.
Can I just jump in and say that link time optimization should be taken off the table for any large corporation because it's not scalable?
I mean, for now, but I guess, I mean, there might be a reason why it would never be scalable to you. Or
yes, because the whole design of large languages that support large programs is that you can compile them incrementally. One of the great things about translation units is that you take the interface, the header file, which provides a neighborhood, and the neighborhood is compiled against the implementation that is compiled against the client to make sure that's sort of the thing that guarantees consistency across translation units. What you do not want to do is require an entire program to be compiled at once. That is not scaled.
Right.
So this is a great thing we don't want to lose. And I'm not going to digress, but if modules were to do something that stopped that, that would be a problem.
If the use of modules implied that everything had to be compiled at one time, you're saying?
Yes, or even put a strict order of compilation on it as part of the language, I would oppose it. Because one of the great things is, right now today, C or C++, if you had a computer for every translation unit, you could put the translation unit on its own computer. It would run flat out as fast as it could, and then you'd link it, and that's a great thing. And if you don't have that, and if somehow there becomes a dependency order in compilation, we'll lose something special, or we could.
Right. Okay. So what we have in the proposal, ignoring the syntax, is a way of expressing a set of assertions, essentially. I don't think that's the syntax, but essentially it's an assertion that is part of the declaration of the program, part of the interface to the program.
Those are pre and post conditions, and those are the things that we didn't bring to the table, but we agreed to incorporate in what we have. Again, we're not endorsing them. We're saying we understand that people feel they're important.
Right. All right. So there is also, let's just discuss this, because I think it's kind of interesting and thoughtful. It's not exactly what I think you're using in BDE, but there's also these levels of what you said, the assertion level when you were describing it. There's a default, there's axiom, and there's audit. What are those? What is that about?
Okay, well, you mentioned BDE, so let me just tell the viewers what BDE is. When I joined Bloomberg in 2001, I started working on an environment, and at the time, the B was somewhat ambiguous. When it was dealing with my book, it was BASIC, and when it was dealing with Bloomberg, it was Bloomberg. And so BDE stands for Bloomberg or Basic Development Environment. Now it's a recursive acronym. BDE stands for BDE Development Environment. And okay, so having said that, what we do in BDE, every single function in BDE has preconditions that are asserted at the top of the body of the function. And we don't use C-style asserts, we use our own macro, but it's really pretty much the same thing. The only difference there is that between a C-style macro and what we do is we specify a level. So instead of being on or off, we specify, well, how much do you want to spend for us to check? You want it to be a little bit? You want it to be a lot? Or do you want it to be everything you got, even if it violates the essential behavior of the contract? And the standards committee standardized 2 of those 3. They standardized default, which is pretty much everything, except if it violates the big O complexity of the function, and I'll explain an example of that. And then audit says, you know what? Just do it. I know it breaks the contract, but just do it. And then axiom, which is something that we fought over forever, saying why it doesn't do any runtime checking at all. Why would you do it? And the answer is sometimes it's like Heisenberg's uncertainty principle. If you check it, you ruined it. So we know it's right, but we can't test it. So just trust us. And the example of that is if you want to know if an input iterator is valid, or you want to know that the first element on the input iterator is going to be something. If you query the input iterator, you're lost. Can't do it. So what you do is
because it can only be read once.
Right. So you'd say, I know, because I'm smart. I'm a really smart person. Little plug for allocators. If you know how you're using your allocators, you can do better than the compiler. And the same thing here. If you're a smart human being and you know that this thing is not going to be broken because you know it, you can assert it. So that's what axiom is for. But the 3 levels give the owner of the application, or maybe even the owner of each translation unit, or even of each module, the opportunity to say, today we're going to be checking, in the standards case, either nothing or everything we can that's reasonable, or we're going to break the contract, or just trust me?
So for example, if I'm calling lower bound, the prerequisite for lower bound is that the data is sorted. But
Okay.
to know if the data is sorted, I'd have to do a linear operation. But
That's
lower
the
bound is
classic
specified to be logarithmic.
Right.
So
what we're
if
saying is to check what you're saying is to check that we're correct would violate the big O requirement and
Right.
therefore the essential behavior.
So what you're saying is we would classify that as audit, meaning
Yes.
only in an exhaustive checking would we actually verify that all the data coming in is in fact sorted when calling lower bound.
That's correct. Now,
Right.
let me throw in one other thing that we don't do. In BDE, we allow for the possibility of an incompatible build, much like if you build with or without multi-threading, where we're going to do things that increase the size of the structures, like checked iterators. Checked iterators aren't any of those things. They require a separate build mode. And so we've left those out completely from the standard. The assumption is that any module could be built differently, and in theory, the compiler vendor could support this what's notion of a mixed mode assertion level build. Now, it's not talked about. It's not something that we put into the standard per se, but if a compiler vendor wanted to, they could say, okay, you can build this library at a high level of checking and this library at a low level of checking, and the client can build either way. And depending on what's getting compiled actually by the compiler that's invoked, that's the level of checking that will occur. The bad part is that for libraries that use inline functions or templates, it'll be the client's compiler that decides the level of checking, not the library. So that's one of the drawbacks of translation units, and that will be fixed in modules or any module proposal that I would ever endorse.
Okay. All right. So let's see. So what else do we want to talk about in terms of the actual proposal? There is one thing that got me all exercised, and kind of the reason we have this episode.
Weren't there two things? There was the name of the return value too in post conditions, no?
Oh, yeah, I thought that was silly, but I mean, that's obviously, as John would say, that's just syntax. So talking about post conditions, when specifying the return value, how do you specify, when you're writing the post condition, how do you specify? Because the post condition is usually going to say something like, and the return value will be less than this parameter, but greater than this parameter, or something like that. And so it may be that you need to specify the return value. And how do you specify in the code that you're writing? How do you specify what the return value is? To me, the obvious thing was to just use the word return, which in that context would not be a statement, but would instead be understood to be the return value. But I assume that had to have been discussed. In fact, I think it's in the paper that that was a consideration.
I believe that, well, first I have to say this. None of the post condition stuff at all was ever part of the original proposal. All of that was added by people that feel that the code that you're shipping needs to check itself as instead of a unit test, for example. In other words, even if people give you the right preconditions, I'm not even sure if I wrote my code correctly, so I just want to double check. And I can't get my mind around that because it's kind of, to me, like shooting a rocket off to go to the moon and bringing the gantry with you. No, the rocket goes by itself, and you should test it before you shoot it up into the air. And the post conditions are really there primarily for static analysis.
I find that interesting. So you're from your point of view, the post condition checking should be done as a unit test only, and there's no point in having it in your code.
My rocket ship spaceship analysis or analogy is really how I feel that it is something. The testing is something that you do back at the launch pad, but it's not something you send off into space. By the time it goes out into production, that kind of checking, the kind of unit test checking, is done. What you can't do in space is make sure that everything that's coming into you is done properly, because not all the aliens out there respect contracts. So you really need to trust, but verify that people are calling you properly. And that's what I mean by defensive programming, which is you're defending against client misuse. You're not defending against your own incompetence.
Okay, all right. So, Kevin, what did they finally decide to use as the name? I said it should be returned, but what did they decide?
Oh, it's really just like you write ensures, then you write the modifier, and then you just introduce a name. So ensures, axiom, then you say return underscore value, and then you use that name. It's really just, I mean, it reads somewhat properly, but as you say, it might be a bit of a waste, but you know, it's just bike shedding. So I'll gladly take this solution over having to wait another standard. So
yeah. That was what I just looked at it and said, you guys made the obvious bonehead problem. But I'm with you, Kevin. It was not significant. The thing
it was extra safe. I just want to say it was extra safe, and I had the same reaction, that people just didn't want to have any kind of worry about context sensitivity or anything with they just didn't want to deal with it. And here it gave a little bit of extra wiggle room for each person to do their own thing, and so people liked it. And as I said, I had no dog in that. Is that a dog in the fight or whatever, horse in the race, or skin in the game, or any of that? I really didn't matter to me at all. So whatever made it work was fine with me.
All right. Here is the here's the problem I had, and now I see what you're saying. You may not care about this one either. In fact, you might even agree with me. But when writing the post conditions, those are going to be valuable to someone looking at the function, because not everyone documents their function as nicely as John would have them do so. And so reading the post condition in code will help me understand, or maybe just reinforce, perhaps the wording in the description is correct, but I'm a little bit skeptical. Did you really mean that? When I look at the code, it's like, oh, no, they really mean it. That's what they're saying. This is what's going to happen. They're specifying the post condition. So I can read the post condition and have a valid sense of what the meaning of the expression is. And what upset me about this as I read it, and I understand why, and we'll discuss that, but in the post condition, if you reference the values of any of the parameters, which of course people will, the post condition will be expressed in terms of the parameters you pass in. The value of the parameter is not the value that you passed in. It is the value that that parameter has at the end of the function. So if the parameter is modified by the function, which of course, if you pass something in by value, then the function is in fact free to modify that object. And if they do so, then when they reference the name of the parameter in the post condition, the value that's being used in the post condition is the value that that parameter has after the function is executed. Now, to me, that means that this is meaningless, because I can no longer look at the interface of a function to try to understand what it's doing, because the post condition is going to say, for example, the return value has to be less than the parameter you passed in. So you pass in A, and the return value has to be less than A. Except I don't really know what A is. A is not the value I passed in. I actually have to read the function and understand what the function's doing to A in order to understand what the post condition is telling me. And to me, that makes it useless.
I'm not sure what is the specific point. Right now, you're saying you pass something in by value, and therefore whatever the client sees doesn't change, right? So
no,
what I'm saying
is that you're documenting your function, you've written your preconditions, fine. I pass in A, and the function calculates which value less than A it's going to return. Well, that's part of the problem, is I don't know what it's returning, because what the post condition says is that the return value has to be less than A. And in order for that to be useful to me, because the way that the feature is specified, which I agree with that part of it, the post conditions and the preconditions are part of the interface to the function, meaning I put those in the header, but the implementation is somewhere else. It's in a .cpp file somewhere. At least theoretically it could be. Of course, I could make it inline, but I can't see what the function is doing. What I see is these are the post conditions, the preconditions, and the post conditions. And when I read the post condition says that that the return value has to be less than A. But my point is that tells me absolutely nothing, because I passed A in. It's a value parameter. It's an int. So I pass in an int A, and the post condition is saying that the return value will be less than A. Now, if A is guaranteed to be the A that I passed in, which is what I think it should be, then that tells me something. Oh, it's telling me the return value will be less than what I pass in. However, that's not what A is. The value of A is the value that A has at the end of the function. So if I pass in a parameter A, and inside the function increments A in some way, A is now much larger than it was when I passed it in, the post condition is not telling me anything useful at all.
Okay, so I'm going to ask a question. Are you sure you're right?
I'm pretty sure, because it specifically explains that. I mean, it calls that out itself. It doesn't just casually mention it. It says, note that this is the case.
Okay, I'm going to question
I've got the document
that.
in front of me, but I'm not sure exactly where it says that.
Can somebody verify that it says that it does that? Because that sounds wrong.
It says there is no way of referring to the old original value of an argument in a post condition.
That means you can't. You can't refer to, you can't do that.
You can't refer to the old, the original. You can only refer to the final value.
I think what it is that the old and the new aren't allowed to be different.
No. That is not what it's saying. What it says,
if they are different, you're not allowed to use.
If you refer to an argument in a post condition, the value used, if the post condition is evaluated, is the value of the argument at the point of return.
That's not a by value argument. That's a by reference argument.
It does not say that.
Well, how could it possibly?
In fact, the example it gets, it says, well, no, wait, I'm sorry. The example, there's an example on that point. I'm sorry. But you see, I understand why they did that. The reason they did that is because I could pass in an argument that can't be copied. And if it can't be copied, there's no way to preserve that original value. And so what that means...
Okay, hold on. I think let's just take two cases. Case number one.
Okay.
Case number one is it's passed in by value.
Mm-hmm.
Whatever happens inside the function is nobody's business because it's not exposed. So if it's passed in by value, for sure. Otherwise we have a defect. When somebody refers to the public interface of the function, they are referring to the value that was passed in. There's no other way to interpret it, and I have to assume that smart people looked at it and they did the right thing. Now, if that's not the case, then we have a bug. There's no question.
We have a bug.
All right. So I will. Here's the if. If what the proposal says, and I don't have it in front of me either. And as I said, this is not the important part to me because this is a post condition, and what I'm concerned about are asserts inside the body of the function.
See, that makes it clear to me why this bug could have slipped through, because as you said, you didn't. I was surprised at this.
Okay, but I am not. I'm more than surprised. It makes no sense at all.
I agree.
So I'm not even willing to believe 100%. Although I trust you, I need to verify that what you're saying is actually what was meant. Even if the proposal says what you think it means, they didn't mean that. And if they did mean that, then I have a problem.
Well, so here's the problem, John. Think about this. It is possible in modern C++ now to pass in an argument that is neither copyable nor movable because of copy elision.
Yes.
Okay. So here is an argument that I'm giving you. It has some value, but it is not const. Inside the function, that argument can be changed.
You can't pass in by value something that can't be copyable, so we can take all of those off the table.
Yes, you can.
How are you going to pass. Okay, so you're going to pass an argument in by value, but what that means is you're going to copy it in.
No,
not in C++
copy
17. Right?
Oh.
Yes, copy elision is now mandated. So it is possible for me to create a temporary in the place of a parameter. So it's possible now to have a parameter that isn't copyable or movable. But even if it's only movable, you still have the same problem. And the problem is I've passed you a parameter which the function is free to modify. If in the post condition, if I refer to the value of that parameter, how can the compiler recreate what the original value was? That's the problem.
I'm going to go with this. If you pass in, let's just take an example. I have a function square root. It takes a value that's a double. Now, if you pass in 5.0 to that function and you say that the value returned, let's assume, I'm going to just make this simpler. Let's say that the input of the function is restricted to be greater than or equal. No, I'm going to make it even simpler. It's going to be greater than 1. Okay? I'm just going to say that the function is going to accept something that is strictly greater than 1.
Okay.
The post condition is going to say that the result is less than the input. So the input, I've got square root of a. So now my return value is going to be strictly less than a.
And your post condition actually has that expression.
Yes.
Okay.
Now
here's
go ahead.
Well, I was going to say, here's the problem. Without seeing the implementation of the function, you can't know that the function didn't modify the value passed in.
Okay.
And if it did modify the value passed in, then the expression is using that modified value, not the original value.
Okay.
And I completely agree with you that makes sense.
I'm going to tell you that example that I just gave you and what you just described to me is a bug. It's nothing but a bug, which is why I believe that you're misinterpreting what they meant. Not what they said, but what they meant.
No,
because no one would possibly think otherwise.
No, it's because it can't be implemented otherwise.
No, well, but that's the lamest excuse for anything. If it can't be implemented otherwise, then don't implement it.
Well, see, that's why I think there's actually another path, which is in those situations where it can't be implemented, you don't implement it then.
Yes, that's what I'm saying. No, I totally agree.
Okay.
But I think it can be implemented.
No, because here's the problem. As I said, I can have a parameter which cannot be copied. Maybe it's movable. In 17, it doesn't need to be either. It can be a non-movable, non-copiable feature, but that's fine. Suppose I have a parameter, I've moved it into my function, so it's a movable parameter, but it can't be copied. So the compiler can't make a copy of it, and it's not const. So the function can modify it. In the post condition, if I write a post condition based on that argument, what can the compiler do? There's no option. Now, see, I understand, and I would say that there should be some stipulation that says if the passed-in parameter can't be copied, then the post condition is never evaluated. It can be stated so the user reads it, but it's never evaluated. That's the only thing that can be done, because if you can't copy but they didn't want to do that. Instead, they wanted to say, oh, it's always computable, so we can always determine what's undefined behavior, and we can optimize based on it. But in order to always compute it, you have to specify that it is the final value of the parameter.
Okay, so let me just say this. I think we've gotten to the point where we've identified a question for somebody to answer. Not me, but here's the question. Seriously, here's the question that we have to ask. I'm a client. I have a square root function. It's a cheap function. It doesn't work for any value that isn't greater than 1. My post condition is that the result is going to be less than the input. Inside the function, am I allowed to screw with the input and just say, but right before I return, I'm going to set the input to 1 billion. Yeah. Is that going to fail the post condition? Because I promise you, if that fails the post condition, the whole thing is nuts. The second thing is that never mind post conditions. If I have a function that passes something in by value, and that value is observably changed from outside, that's nuts too. So when I say by value, I mean something like somebody passes in, the function signature looks like double of A and you pass in whatever. That's what I mean by pass by value. That's going to make a copy. That certainly has to continue to be true.
All right. So in the chat, I think there's a clarification from the latest revision of the latest paper. It actually shows. Maybe you could look at it, John. But
please, where do I look?
Yeah, it's on Slack, right? So it shows, for example, a function which passes an x, an integer x by value, and ensures something about x. And if you, I think it actually says that if you modify the parameter, you have undefined behavior.
Yes, that's fine. So
right.
In other words, what they're saying is, this is what I thought. So in other words, what they're saying is, you go ahead and write everything you want, but as an implementer, you own the post condition from a maintenance point of view. And if at the end of your function you decide to screw with the parameter, you just ruined your program. It's undefined behavior. It's not. In fact, if that predicate executes at all, it should absolutely be undefined behavior. Absolutely.
All right. So remember to mark your parameters const if you're going to use post conditions.
No. That's an overstatement. Just don't modify them.
Sure, well, that too.
Then they should be const.
Well, if you want to, but I'm also going to say that there's a cost to putting more verbiage in text, and that's something that I'm concerned about. So, for example, if you had a one-line function, and you had the signature in one file and the declaration in one file and the declaration and definition in another, and you happen to want them to match because you're passing in int x, and you didn't put constant x because it's a one-line function, I would prefer that personally, being an old person, been around for a while, because the extra const looks pedantic to me, but it's purely a matter of style. There's nothing wrong with it, but I wouldn't say that it's mandatory. I would say that use your judgment. If you don't want to put in the const because it's not necessary, then don't put it in.
But I think we still have a problem here, because the problem is in the specification of the wording. If this is the only change they made, it's not enough of a change.
Well, tell me what the problem is.
Because the problem is that I want to be able to read the post condition and know that the intent is that we are comparing the parameter values passed in, not the parameter values final. And
okay,
that's what this function, what the document clearly says, that we used the final. Now, this is saying if you change it, it's undefined behavior. But
right.
What that means is, I'm not sure exactly what they're trying to say, what that means. I don't know what that means.
They're saying they want to defer implementation of this till later. That's just what you said. They said they don't know how to do it right. They want some more input. They want to get this into 20, and they want to learn, what do we want to do about maintaining the current value, or do we want to use the final value? And they're not talking about by value passing. They're talking about by reference passing. And there they decided, you know what? We don't know which is better. Should we refer to the initial value? Should we refer to the final value? Because the client knows only the initial value and only the final value, doesn't know any intermediate value. And it would cost to choose one or the other. And so what they're saying right now is, you know what? We're not going to decide. We're not going to do that right now. We're going to leave that off the table so we can get this through. Now, my feeling is, by all means, as much as you can leave off the table, leave it off, because this is not the important stuff. The important stuff is making sure that if you have 6,000 engineers using some infrastructure, that all of them, we trust all of them to do the right thing. But if they happen to make a mistake, we want to be able to catch them and send them a nice message saying, excuse me, you have a problem. Would you please fix your code?
All right. This didn't work the way I expected. This is actually great. This is wonderful.
I think we can summarize that by saying, yo, dog, I heard you like contracts, so we made contracts for your contracts.
Right. So, yeah, that's a good one.
All right. If what you're saying is that they have just kicked this can down the road, because it's potentially a rare case that people are going to modify. I mean, I think most by value parameters are not modified. There are times when people do modify for example, the begin passed in is usually modified in a generic algorithm, right? We usually increment begin until it equals end. That's very, very common. But most of the time, for example, with a square root function, I would be surprised if the parameter passed in was actually modified. It's passed
John,
in by
I'm going to ask you, do you believe that when we increment begin until it gets to end, do you believe that that's visible outside the function?
It is if you put begin in your post condition. According to the standard, it's saying, according to this proposal, it's saying that the post condition has the final value. It says the value at the return point. That's the problem.
It's also saying that if it's different from the original, it's undefined behavior. So
that's apparently a revision later than what I got, because the reason document from and I'm just using what Bryce published in his trip report that was on Reddit. That's what I was looking at. If there's a more recent version, I don't know. I didn't see that version, and I don't actually know what got voted in. Of course, I'm just going by what Bryce posted. So he may not have posted the very latest version.
So it's visible only from what you're saying is it's visible only from the post condition. And one of the things that I jumped up and down about at the committee was they wanted to put in that you could put in a precondition reference to private data when you're in a public function. And I said I would withdraw from the paper. I said I would withdraw from the paper if they tried to do that. And this is the same idea. I would withdraw from the paper. So that's how strongly I feel about it.
Yeah.
I could not agree with you more, John.
Okay. Wow. I appreciate that. So what else do we want to talk about here? We've blown through an hour. Yeah. And
we're actually not quite to an hour yet because we started late, but we do only have a few minutes left before the end of the hour. I did want to say that one of the reasons that I invited Kévin on was because I didn't want to hear just from the authors of the paper, but also to hear from the sort of the end user. And I know that Kévin has been interested in contracts for some years. So wanted to get his reaction to the proposal.
I have my own interest, but I think I'm going to talk about other people's interests just to add a bit of other perspective there. So, for example, do contracts mean we'll be able to get rid of the Lakos guideline for no accept? That's a thing. I know from the paper, probably not, but maybe you have something else to say.
Okay, well, you say the Lakos guideline. I think Alistair Meredith is the one that wrote it, and it's so far, it was written in a second. I want to just mention for people to understand that in Madrid, we were trying to figure out, because no accept was invented very quickly. It was invented for move construction, and it was necessary because otherwise we wouldn't get the algorithmic efficiencies of a move. And we want that. That's a very important thing, right? But then people said, well, as long as we have that, I speculate that if we put no accept on a bunch of stuff, that the code will run faster. Well, there's no evidence of that. There has been no evidence of that. There continues to be no evidence of that. And in fact, when you put no accept on something, you might generate more code than take it away. But that's not even important. When people start worrying about optimizations like that instead of what's right, things go south. And that's what happened with modules, just to let people know that modules have to be done right, and then they'll make the code fast. But back to contracts. So the thing about no accept is if you have a function like the bracket operator where there is a possibility that you'll get an in vector, there is a possibility that you'll have undefined behavior. It would be nice if the person specifying what happens when undefined behavior occurs could throw. But if you label such a function that has preconditions no accept, it means that when a precondition is violated, you actually defined the behavior. You've said, well, it can't be a throw. We said that. And so no accept in effect defines undefined behavior. And I hope everybody hears that exactly what I said. What used to be undefined behavior is no longer fully undefined. It's partially specified. It says that no, you cannot throw. And I find that abhorrent because undefined behavior means anything could happen. Your cat could get pregnant even if you don't have a cat. Now you're saying, no, it can't. And that's absurd. What you do want to do is you want to allow people under certain circumstances to do what they need to do. And one of those things is in testing or in a controlled environment, if somebody calls something out of contract, I may want to throw and say, I have a problem and catch it. Now, the time that you want to do that most, very much most, is during testing. And then the rest of the times, instead of throwing, what you'll probably do is a long jump, save your data and get out, or you'll send a message to the console, or you'll do whatever you're going to do. But arbitrarily saying, no, 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 I don't care, Mr. Application Developer, no, you don't have the right to do what you want to do, is abhorrent. That's my comment.
Okay, so would you say, for example, that people who actually measure performance improvement from no accept, in fact, could get it otherwise? For example, if the compiler knew that the function didn't throw, well, it can't do the optimization. No need to force no accept on everyone. Maybe? Okay, so one of the things I would have done if I had cared about exceptions, but I didn't because I don't believe in them at the time. Now I do. Because I learned, you know, I'm back in 2000 and God knows when this was all being discussed. I was like, exceptions, how does that affect me? I think it was in Pittsburgh. And so Alice was like, really? You don't care about no exception? So anyway, things change. What I would like to see is I would like to see a sharp distinction, much the way modules do it, where there's a difference between what you tell the client and what you tell the compiler. So in modules, for example, you can tell the compiler that a point has 2 integers and it's part of a box, and the client can create boxes, but the client can't create a point. And then when you change point to be something else, and the box no longer uses point, clients can't go ahead and create instances of point on their own because it was never intended for client use or to be maintained in perpetuity. I'd like something similar for no accept. I'd like no accept to be visible to the compiler, but not visible to the human being. So when something is labeled no accept, it might go away tomorrow. In other words, no accept is a hint to the compiler that today, by the way, today, nothing's going to happen. But tomorrow, it might. I might take it away. And so, unfortunately, when people put no accept on a function, they use it to try to tell the client that this thing isn't going to throw. And I'd rather them not do that and just write in English, dear client, this is not going to throw. And then I put a macro up there. Yes, I said macro because we don't have the feature that says, if I'm not doing checking, go ahead and tell the compiler this really is no accept. And that would solve all problems. Well, that's interesting because it seems you view it the other way around. To me, I viewed no accept as this thing that says, okay, I put no accept from now on, this function will never throw. That's part of the contract. And maybe for the compiler, I should get another tool. Because I know no accept, it's a feature you can query. At compile time, there's a no accept operator. If I'm writing a strong exception guarantee function, I would like to query sometime, can this function throw? Can I do this thing? And, if I just want something that will remove the exception handling, maybe I should use something else.
Okay,
well,
so here's
perhaps the solution to this is to specify in the precondition that it's no accept if you follow the precondition.
Okay, well, that's part of it. Hold on. That's what we're saying. That's what we're saying. It's no accept if you follow the precondition, and the precondition, if you don't follow the precondition, there is no postcondition because it's undefined behavior. And that's important, and I don't want to give that up. Now, let me say something else. Another property of contracts that has to be respected and absolutely respected, we don't want to relax it, is that whether a program is checked or not, its meaning is the same. And I'm going to throw out another name that I love to throw out. One program has to be Liskov substitutable for the other for all valid programs. And what that means is either one does precisely the same observable behavior. The only difference would be in the instruction stream that occurs during the predicate check. Now, if the predicate check fails, sure, a side effect could occur, but that's not a problem. But for all correct programs, a checked program and an unchecked program do precisely the same thing, have no side effects. And when I introduced Lisa Lippincott, she said, well, wait a minute, John, a checked program does have side effects. And I said, well, what do you mean? She goes, well, the extra instructions will dissipate heat, which will contribute to the eventual heat death of the universe. And so I said, okay, but for mere mortals, what a side effect means is that there's an observable change possible in the future, and we're going to say no predicate is allowed to permit an observable change. So that's really important. Otherwise, if we did what I just described, you could imagine a program that is checked, that works, and then as soon as it goes to the unchecked mode, we get a different code path, and then things don't work. I had that happen once to me in my life with assertions. I had a side effect in an assertion. I did it once, checked the entire program. It worked perfectly. I built it and optimized and shipped it, and it didn't work at all. I was very embarrassed. It never happened again.
Right. Yeah. I've been on projects. I don't know that I've done it, but I have been on projects where that happened. It would be delightful if the compiler could tell us if an assertion had a side effect. But
yes,
we need to wrap this up. I've really enjoyed having both of you guys on, and I'll make a promise to Kevin next time you're on. I'll actually let you speak.
I mean, invite a guest that's not as knowledgeable as John Lakos, at least.
Well, we do.
I'm really very flattered. Thank you, and I'm sorry I sort of dominated this.
We love having people on the show that have opinions, because that's what this show is really about. It's about giving us a chance to vent our opinions. You heard me rant and rant and rant. This was something I really wanted to rant about, and so it turns out John was not the right guy to rant at, and I thought it was, and so that's why I said this didn't work out the way I thought.
But maybe I was, because maybe I agree with you, and if you really do have a problem, well, we can just let them know.
Well, no, I think
the authors.
This revision has kicked the problem down the road, which I'm okay with. At this point, you can look at a post condition and you can say to yourself that either this post condition is based on the passed in value of the argument, or the entire program is undefined.
And you can assume that it's not undefined, because if it is, there's no point in calling the function. So you can play compiler and say it's all good.
Yeah. So so that is kicking the can down the road, and I'm okay with that. I think that's okay. And I wish I had been aware that there was a follow-on. It never even occurred to me there might be a revision to this document as I read it.
I mean, it's a paper that's currently locked behind a password, so I mean, you couldn't know. It's just someone pasted it on Slack. So
okay, all right. Well, that makes me happy. I'm happy about that. But I'm not happy that we've overrun. So we try to keep this within an hour. But I want to have both of you guys back, and I think it's been fun, and I've had a lot of fun. I hope you guys did too. That's the point of the show.
Absolutely. Yeah. This is great.
Right. So let's wind up and wish everyone safe coding until next time. Safe coding.
Safe coding.
Bye.